In this demo, I will be showing you how to migrate SAP SQL Anywhere database objects to PostgreSQL using one place. So I have two deployments in this particular scenario. One is the source database deployment and the other one is the target database deployment. So I have two one-place deployments. Now I'll first log into the source database, which is a SAP SQL Anywhere database. I am able to successfully log in, and my deployment name is US Dallas, just for a naming reference, right? And I will try logging into the PostgreSQL deployment, and my PostgreSQL deployment name is UK London, just for a reference, right? So there are two different deployments for the source and target databases. So initially I will configure the source database. So in this case I will add a database. I already have a database credential inside my one-place deployment, which is US Dallas source database, right? So I will select that the alias name, right? The username is 1p user, which is the database user inside the source database, and the password, right? And then the source database is running on port 2638. Source database name is IMSDB, right? Since I already have the credential details, I'll just view it and see if the connection works fine. Yeah, the connection works fine here, right? I have the IMS database name and the product is SQL Anywhere and product version is 17.0.11. Okay, so my source database is configured successfully. Now I would like to see how my target database connection looks like. Similar to SAP SQL Anywhere, I do have a credential called pg_db here. My database username is Postgres and the password is whatever password you have given for the Postgres database user. And Postgres DB is running on port 5432. Postgres database name is cusdb, right? So I will select that and I will view the details, and I'm able to connect successfully to the target database as well, right? So now back to the source database, we have to do the analysis of tables in order to make sure that all the tables and columns are compatible to a PostgreSQL database. So I will select the tab table. I will select the alias name which we created before, get details. Now I will choose the schema details from that source database, and I will start analyzing my objects inside the source database. It'll take a couple of minutes to go and look into all the columns, the data types, the column width, whether it is a not null column or whether there is a primary key associated to that column, and what are the default values for that column, right? So once the analysis is complete, it will generate a report. Okay, so here I can see the report here. It has completed the analysis and I can actually generate the report here. So in the report clearly shows that PostgreSQL doesn't support keywords such as window and offset as column names. So we have to change those column names on those tables. So we have to discuss this with the application team and change those column names in the application as well, depending on the application code, right? Okay, so based on that, I have renamed the columns on the PostgreSQL. So so the next step is to migrate the tables which we analyzed to the PostgreSQL database. So I have a menu called heterogeneous initial load. So in this case I have my source deployment, source alias, and the schemas which I have to migrate. I'll gather the metadata, give a job name for this metadata, and I will choose the target deployment and the target database credentials. So it got source and target got connected to the database successfully. Now I will start analyzing the objects on the source database. So it goes and analyzes all the objects and collects the metadata needed for the migration of tables. So it actually is going and fetching all the database metadata credentials from the source database. Okay, so I done completed all the analysis, and it shows that there is at least 2341 items tables in the DBA schema, right? So now I will go ahead and apply the metadata onto the target database. So it goes and creates all the tables in the target database, converting all the data types using the not nulls and the default data types and the default Postgres to the default Postgres database as well. So in this case it got created successfully on the target database. If there is any error, it will show the error as well. So all the databases 2341 tables are created on the Postgres database successfully. Now the next thing is to migrate the views and procedures and triggers accordingly, right? So I will choose one of the schemas, which is a DBA schema, right? And here my source database view metadata is displayed over here, right? My target is also displayed over here, right? So the source and target connections are established. Now I will just try converting it, right? So it goes and converts the corresponding details accordingly on the target database, and then it actually goes and creates the view successfully. In case the first phase is failing, we can actually go and do a retry, which helps the view to or materialized view to get created on the target database successfully. We have automated the view creations and the procedure creations and the trigger creations as well. So it actually goes and creates all the views and details on the target database. Similarly, I will show you the automation details of a procedure or a function, right? So in this case, I'll choose my source database and my source schema. Here you can see there are almost 2420 procedures and views, procedures and functions, right? So I will choose the target deployment also here. So the target database is connected successfully. Now I can either convert it one by one, or I can convert it convert it using an automated manner, right? So in this case, the views are already existing on the target database. So let me convert it so it goes and automates all the object creations on the target databases accordingly. So you can see that some of the procedures are or functions are failing. So this function is log count. It needs an internal rewrite of those lock concepts. So we have to rewrite that particular function to the PostgreSQL database, and similarly for the DB lock connections, DB connection from lock as well. So those has to be rewritten. You can actually see those logs as well and see what's causing this error to be not getting created on target database, because local temporary table SA logs is not is an invalid type on the target database, right? So we have to rewrite this function accordingly. Similarly, check visit with difference, right? So this is also involving that specific conversion. So you can see that what is the difference over here, and the error is also here. So it's looking for a cursor which is causing this issue. So we might need to rewrite a little bit of the code over here which is causing this issue. Okay, so similarly you can see that although all those object creations are going on, and it gets automated. So once the automation is complete, it'll actually generate a report, right? So one of the similar reports what I see over here is on this so this is a report which got generated, right? So in this case it actually lists all the objects which are created, and some objects are not loaded, which means that we are not able to get that source code from the source database for some reason, right? We have to analyze those, why we are not able to load those. So in a summary, we were able to analyze half of the objects which are procedures and views on the source database. We were able to convert more than 50% of the objects, and almost 391 objects are having errors, which can be improved a little bit more to complete those to automate those errored objects as well, to get converted to a PostgreSQL corresponding object, right? So that is how the procedure and function conversions works. Similarly, for triggers, we can convert the triggers through one place to a Postgres format. So in this case, I will choose the DBA schema, and I'll choose one of the triggers, choose the target database here. I'll convert it online. So it goes and checks for the source code and converts that into a Postgres compatible format on the target database. Okay, so here the function and the trigger got created successfully, and the table is existing over there on the collection follow-up. So we might need to create this particular table on the target database, but it actually converts that trigger into a corresponding format on the target database. Similarly, we'll look into another trigger. Choose one of the triggers here. Okay, we'll convert it. Okay, so it got converted successfully into a Postgres format, and then you can save it. In this case, you might be looking for the particular table, so the table might be existing in the DBA schema, so it created successfully, right? So similarly, you can do the views as well in the similar way by converting those views into the corresponding PostgreSQL format. So I'll choose one of the views here, and I'll choose one of the materialized views here. Then this view is already existing on the target database. We'll choose another view, and then it got created successfully. So similarly, we can automate this as well by creating all the views in an automated manner, thereby recreating all the objects on the target database in the Postgres format successfully. So that concludes the demo. Thank you.